Imagine a world so far away, it takes light 40 years to reach us. Yet it might hold the key to answering one of humanity's oldest questions. Are we alone? The James Webb Space Telescope, JWST, is now peering into the mysteries of TRAPPIST-1e, a rocky exoplanet orbiting a faint red dwarf star, to see if it could host life. But here's where it gets tricky. Just being in the so-called Goldilocks zone, the sweet spot where temperatures could allow liquid water, doesn't automatically mean a planet is habitable. Venus, Earth, and Mars all sit in our solar system's habitable zone. Yet only Earth is alive with oceans and ecosystems. So what's the missing ingredient? An atmosphere. And that's exactly what scientists are racing to find in TRAPPIST-1e's data. TRAPPIST-1e, the fourth of 7 Earth-sized planets in its system, has long been a prime candidate for study. However, new JWST observations reveal a puzzle. The planet's atmosphere, if it exists, might be hiding in plain sight. Ryan McDonald, a researcher at the University of St. Andrews, explains that the red dwarf star TRAPPIST-1e orbits is throwing scientists for a loop. The star's activity, like star spots, is muddying our data, he says. We're left with 2 possibilities. Either TRAPPIST-1e has a thick, nitrogen-rich atmosphere like Earth, or it's a barren rock with no air at all. And this is the part most people miss. The JWST's current data can't confirm either scenario. To analyze the planet's atmosphere, astronomers used a technique called transit spectroscopy. When TRAPPIST-1e passes in front of its star, gases in its atmosphere absorb specific wavelengths of starlight, creating a chemical fingerprint. But star spots and other stellar features complicate this process, forcing scientists to painstakingly clean their data. We're talking about removing contamination from the star's light to isolate the planet's signal, McDonald says. It's like trying to see a firefly in front of a searchlight! Exclamation point. The stakes are huge. If TRAPPIST-1e has a secondary atmosphere, formed after a planet cools, unlike Earth's primordial one, it could mean the planet has geological activity, or even a history of volcanic eruptions that replenished its air. But if it's a bare rock, it raises questions about how such a planet could retain heat or water. And this sparks a debate. Could a planet without a thick atmosphere still support life in some form? Or is Earth's atmosphere uniquely necessary for life as we know it? The good news? The JWST isn't done with TRAPPIST-1e. Over the next few years, scientists plan to gather nearly 20 more transits, each one sharpening the picture. We're finally equipped to study habitable worlds beyond our solar system, McDonald says. This is the dawn of a new era in astronomy. But here's the twist. What if the answers don't come from TRAPPIST-1e at all? What if we're looking in the wrong systems or missing something fundamental about how life arises? Share your thoughts in the comments. Do you think we'll find life in our cosmic neighborhood? Or are we chasing shadows in the dark?